Okay, so the last previous example, which is example 2, we have looked at the example where you are given an incomplete double integral, which means that you have to determine the order of integration and also the limit by using the information provided. Okay, so hopefully you can get an idea about that. So next we look at the example 3. So this one is a question from the past year test. Okay, so the question asking just like the example 2, where you need to determine the order of integration yourself, and also you have to determine the limit of the x and y, okay, based on the region, so the region provided. So here we need to know the region first. Okay, so we have the integrand a y squared dA over the region R, where the region is bounded by the y equal to x, y equal to 1, and y-axis. So now you need to sketch the region first. Okay, so now based on the information provided, so we got 3 lines there, where we have we have the region lies on the xy plane. So the first line belongs to the, okay, I start with the y equal to x, and then we have the y equal to 1, and then y-axis. Okay, we have a y-axis here. Okay, so sorry, y equal to 1. So this is y equal to 1 and also y-axis. Okay, so this one y equal to x, and this is y equal to 1, and this line is y-axis. So obviously we can see that the region where it should be bounded by all the 3 lines is located here. So then you have to shade. So this is your R. Okay, so now we already obtained the region. Okay, now it's the time for us to determine the order of integration. So in order for you to determine the order of integration, so firstly you have to look at the integrand. So in this case, our integrand given is ay square. So we have only a bit quite simple expression, e to the power of y squared. Okay, so the exponential of y squared. So now you want to integrate this expression. Okay, so now you have to ask yourself, is it okay if we integrate first with respect to y, and then after that x, or it is more simpler if we first integrate with respect to x, then after that y? So what do you think? Okay, so firstly, maybe as for now you have no idea what the answer is. So now we just try an error. So let's say we are choosing dy dx, which means that first you want to integrate with respect to y. So now we just imagine first we want to integrate with respect to y. Okay, so tell me what is the limit then? Okay, so meaning that in this case you are choosing the x constant, right? So x constant, which means here you have to provide the vertical line. Why we need that? Because this will help us to determine the limit of x and also the limit of y. So you choose the x the outer integral, so x constant. So as you can see here, you should know the value, the intersection value here. So as we know that this one is y, and y equal to 1 intersect with the y equal to x, at this point. So now when y equal to 1, so x should be 1. So now you can see that from this one, this orange line, which is a vertical line, why we have vertical? Because you are choosing x constant here, right? So you can see that x, so just read the x-axis. So this line, which is passing through the region here, should be lying between x equal to 0 and x equal to 1. So the highest value of x is 1. So 0 to 1. So now we look at the limit of y. So based on this line, so then we can say that when you read this, from the lower value of y to the upper value of y, so on this direction along the y-axis, so the first point, the initial point that you can see is that point, and the terminal point is that point, right? Okay, so your lower bound for y, so you have y equal to x. So y equal to x. And then you keep going upward. So you have y equal to, so this is the line belongs to y equal to 1. So now if you are using, let's say I provide the complete double integral. So you have dy dx. So x is 0 to 1. And then y is x equal to 1. So now we want to proceed with the integration. So the first one, you have to integrate with respect to y. So now we want to see whether it works, becomes simpler, or it becomes more complicated. Okay, so now you have the y squared here. So it looks like if you have just y, so we should have no problem, because ey, you integrate ey, so you will get the ey back, isn't it? But now you have the y squared. It looks like you have to, okay, the simplest method of integration that pop up in your mind now is substitution, right? Direct substitution, where you let u equal to y squared. So hopefully after we transform from y into u, so we have a more simpler expression. Okay, so then what is the next step after you assume that you now want to assume that u is equal to y squared? So next you have to, because our idea when you apply the substitution, you want to change this into u. All this from y should be just in terms of u. So you have to replace the dy here. So how can you replace that? You can get dy from this expression where you need to differentiate. So du dy will give you 2y. So you need the dy, right? So dy equal to du over 2y. So now let's try to substitute all the expression that we have into the ey squared. So ey squared now becomes, so ey squared dy now becomes, so you have eu, and then you replace the dy is du over 2y. But then you cannot proceed the integration because your y still there. If the only thing left in terms of u, then you can proceed to integrate respect to u. But now your y still there. So what we should do next? So you have to try to eliminate the y by using any possible technique. So maybe you can rearrange. So your y is plus minus square root u. So eu over 2. Now you have to deal with the plus minus u du. Okay. Okay, let's say we ignore the plus minus sign. But now, from the ey squared dy, so it is now transformed into more messy, right? The expression becomes more messy because now you have eu and over square root of u. So I'm not saying this cannot be solved, but since we have another option by changing the order, so we don't, let's say we don't, I don't want to proceed this. Okay, not because of this is cannot be solved. Maybe it can be solved by using any other technique, which means that you transform that into another form using series or whatsoever. Now we'll want to choose a different order. Okay, so now we want to see. So I just stop there. Okay, now I want to use the dx dy. Okay, so now let me change the double integral now is become y squared dx dy. Okay, so since we have to change, we want to change the order now, then you have to look again the region, because you have to determine the limit now. So which means that your y now is function. So y is constant. So when y is constant, so we so we have now, because y is constant, so the line that you have to create should be horizontal line. So you can see that your y constant is lying between, so the smallest y is at 0 and the highest y is at 1. So 0 to 1. And then now we want to look at for x. X is a function now. Okay, so you read from the left to the right along the x-axis. So from the left, you just keep moving to the right slowly. And the initial point that you can see is that, and the terminal point that you can have is that. Okay, so now look at the initial point. So initial point, so this point is part of the line of x equal to, so you have a straight line here. So this is at y-axis, which means that y-axis is x equal to 0. Okay, and then you go to the right along the region, and your terminal point is located here. So this point is part of the line of, because now you have x equal to, so the original expression is y equal to x. So now you have to read x equal to. So you have x equal to y. So that is your limit, your new limit. So y is 0 to 1, and then x 0 to y. So now we want to work using this double integral. Okay, so now we want to do all the integration. Okay, so we want to solve for the inner integration. So we will have this one. So you have y squared. Then you want to integrate with respect to x. So since now you have e to the power of y squared, and these are in terms of y, so all this is a constant. So which means that when you integrate, okay, I put the answer directly here. So when you have the integration for the first one, the first part of the integration here with respect to x, so you have 1 dx. So imagine that since ey squared is a function in terms of y, so they are all constant. So you just integrate 1 dx, so you will get just x. So the ey squared does not change. So now you have the x. Then your limit is only for x equal to, from x equal to 0 to x equal to y. So then when you substitute the limit, so now you have y squared, and you have y minus 0 dy. So then simplify, so you have y ey square dy. Okay, so now they are all in terms of y. So you go to the next integration, which is all these terms need to be integrated with respect to y. Okay, so yeah, still there is the ey squared, but hopefully the y here can help you to reduce the complexity of the existing form. So meaning that we want to apply the substitution. So we want to simplify the form by using substitution method. So here we assume I'm using u equal to y square. Okay, and then you have the dy here. So you want to get the dy. So how can you get that? You have to differentiate. So du over dy will give you 2y. Okay, so now you want to replace the dy. So the dy. So dy equal to du over 2y. So now you replace back whatever that you have here. Okay, now we want to replace inside the integral. So y eu and dy is du over 2y. Then we can see that the y can be cancelled out. Then you can have a very simple expression now. Just eu du. So now, if you compare this with the previous order of integration, where we know this one, yeah, maybe it can be solved, but you need to have a longer step. Okay, but this one you can use directly. Okay, just direct integration. But first you have to integrate with respect to x, and it becomes simpler after we implement the substitution method. So now we just integrate eu, so you will get the eu. And since the limit that we have is belongs to y equal to 0 to y equal to 1, meaning that you have to replace back. You cannot directly substitute into the eu because this one is in terms of u, but your limit is belongs to y. So you have to replace back what is u. So just now we let u is y squared. So put the y squared back, and now your limit from 0 to 1. So 1 over 2. E1 minus E0. So you will have 1 over 2E minus 1. So that is your answer. Okay. So meaning that if you got the question, you are not only try to figure out what you have to do. Okay, so the standard procedure, if you have this particular question, which means that you are given something incomplete double integral, which mean that there is no order given, there is no limit provided, but they just give you the information about the region. So the first step where you have to provide is sketch the region first, and after that you have to determine the limit, right? And you have to think. You have to think what is the thing that you have to think. You have to look at the integrand, and then ask yourself, is it okay for me to integrate first respect to x, or maybe it's become complicated, and so on. Again, if you're asking me, how can I know that this particular integrand should be better integrate respect to x or respect to y? Okay, I have no specific answer for that. Okay, but sometimes if you do a lot of exercises, so that the idea will come directly into your mind. Okay, but the thing is, if you're not sure, then you have to do something a bit faster. Okay, because it's just like try and error, right? So when you do it something faster and you can see that it looks more messier, then you have to stop and use another order of integration. Okay. Okay, so the thing that I want to say here is you have to do a lot of exercises. Okay, so for you to get more clearer, to get more knowledge, to get more understanding, you have to do exercises. Okay, don't wait until a day before the test or the exam. So I'm sure that it's not going to work for you. So you have to at least every day spend about 10 minutes just to do just only one example for just to practice, and the revision. Okay,